This is SpaceTime, Series 23, Episode 31. Coming up on SpaceTime. A new theory to explain how magnetars are made, Japan's mission to the Martian moon Phobos, and the discovery of new worlds beyond Neptune. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New computer simulations have shown astronomers how magnetars, stellar corpses with the strongest magnetic fields in the known universe, could have evolved. Magnetars are an unusual type of neutron star, and neutron stars are formed out of the remains of stars far more massive than the Sun that have gone supernova at the end of their lives. When a star, say 9 times the mass of our Sun, can no longer undertake the core nuclear fusion process which makes stars shine, the delicate balancing act between the outwards pressure of energy from nuclear fusion in the stellar core and the inwards pressure of gravity cease, and gravity wins, causing the star to undergo a core collapse or Type II supernova explosion. Now, most of the star will be blown apart in these events. However, a super-dense core only a dozen or so kilometers across and composed of protons and electrons crushed so tightly together they form neutronium remains behind, as a neutron star. These objects are so dense that less than a teaspoon worth of neutron star material would weigh far more than the planet Earth. As the progenitor stars collapsing down to form the neutron star, conservation of angular momentum causes the star's rotation to accelerate, often speeding up to hundreds of times per second. However, what turns a neutron star into an even more exotic magnetar remains a mystery. But now a report in the journal Science Advances claims researchers have developed an unprecedentedly detailed computer model to try and explain how magnetars are made. Magnetars give off eruptive emissions of X-rays and gamma rays, and the energy associated with these bursts of intense radiation is probably related to their ultra-strong magnetic fields. The authors say that losing this energy causes magnetars to spin down faster than other neutron stars due to enhanced magnetic braking, something already observed through measurements of their rotation period evolution. The authors say this suggests that magnetars have a dipole magnetic field of around 10 to the 15 Gauss, 1,000 times stronger than a typical neutron star. The new simulations suggest that these incredibly powerful magnetic fields are actually generated through the amplification of the pre-existing weaker magnetic fields created as the collapsing neutron star's rotation first begins to accelerate. Previous hypotheses have suggested that neutron star magnetar magnetic fields are simply inherited from the progenitor star. But that would mean that the fields are determined by the magnetization of the iron core before collapse. The thing is, such a strong magnetic field would decelerate the stellar core's rotation, resulting in a very slow spin, which simply doesn't match the observations we have of neutron stars. One of the study's authors, Thomas Janker from the Max Planck Institute, says that wouldn't explain the huge energies of hypernova explosions or long-duration gamma-ray bursts, where rapidly rotating neutron stars or rapidly spinning black holes are considered the central sources of these enormous energies. Janker says an alternative mechanism would involve the creation of the extreme magnetic fields during the formation of the neutron star itself. The idea is that during the first few seconds following the stellar core collapse, the newly born hot neutron star cools down by emitting neutrinos. Now, this cooling could trigger strong internal convective mass flows, similar to the bubbling of boiling water in a pot on a stove. Now, these violent convective motions of the stellar matter could lead to the enhancement of any pre-existing weak magnetic fields through a dynamo effect, in exactly the same way as the Earth's liquid iron core generates its magnetic field. To test their theory, the authors used a supercomputer at the French National Computing Centre to simulate the convection inside a newborn, very hot, and very rapidly spinning neutron star. They found that if it's spinning fast enough, the collapsing core's weak initial magnetic fields could be amplified up to values reaching 10 to the 16 Gauss. The study's lead author, Raphaël Rayoun from CEA Saclay, says the models demonstrate that spin periods shorter than about 8 milliseconds would allow for a more efficient dynamic process than slower rotation, which wouldn't display the enormous fields created by a strong dynamo. As well as shedding light on the formation of magnetars, these findings also open new windows into some of the most powerful of all supernova explosions, superluminous supernovae, which emit 100 times more light than a usual supernova, and possibly also hypernovae, which are characterized by a kinetic energy larger by a factor of 10, and sometimes associated with gamma-ray bursts lasting for several tenths of seconds, and generally regarded as the most powerful explosions in the universe since the Big Bang. So, the millisecond magnetar scenario provides one of the most promising models for the central engine powering such extreme events. This is SpaceTime. Still to come, Japan's mission to the Martian moon Phobos, new worlds found beyond Neptune, and later in the science report, researchers have found that heart damage is common among patients hospitalised with COVID-19. All that and much more coming up on SpaceTime. The Japan Aerospace Exploration Agency, JAXA, is planning a sample return mission to the Martian moon Phobos. The MMX, or Martian Moon Exploration Mission, will launch in 2024 and visit both of the red planet's moons, Phobos and Deimos. The idea is that the spacecraft will briefly touch down on the surface of Phobos, collect some samples, and then return to Earth in 2029. The mission should reveal new insights about the origins of these two Martian moons, which most scientists believe are captured asteroids, although some suspect could be debris blasted off the red planet's surface by ancient asteroid impacts. Now, if the moons are actually bits of Martian ejecta, then they could have accumulated sediment that was ejected from Mars over billions of years ago, providing information on the evolution of the red planet and its early environment. Then again, if the moons are captured asteroids, their composition will help clarify exactly where they came from and how volatiles such as water are transported around the inner solar system. Of course, this won't be JAXA's first sample return mission. Back in 2010, the agency's Hayabusa mission delivered back to Earth bits of dust and debris grains from the asteroid Itokawa. And of course, the Hayabusa 2 spacecraft is on its way back to Earth right now, after collecting regolith samples from the carbon-rich asteroid Ryugu. They'll arrive here in December, parachuting down into the warmer rocket range in outback South Australia. To find out more about JAXA's Phobos mission, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
They are dead set serious about heading to Mars and ending up on Phobos, I think it is, or one of the Martian moons.
Indeed, that's right. So I'm very glad to have pulled this story out because I know Mars is your favourite planet, and whilst Phobos and Deimos are not part of Mars, well, they're certainly very closely connected to Mars. So they're in orbit around the planet. They were discovered in something like the 1880s, something of that sort, with a strange connection to Pluto. This is coming from the depths of my memory here. Let me get this right. I've written about this, but it was a long time ago. The discoverer of Phobos and Deimos was, I think, related to Venetia Burney. Venetia Burney was the 11-year-old Oxford schoolgirl who gave Pluto its name.
Oh, okay.
So there's a factoid that you didn't want to know. I should check it. It's in one of, I can't remember which book it's in. It's in one of my books. I think it might be in Stark Raving Mad. But yeah, it's a very nice connection there. A nice little link between the moons of Mars and the dwarf planet Pluto. And that's the end of the story, really, isn't it? No, it's not. Well, there is more. So Phobos is a really interesting world. It's about 30 kilometers across. It's got a curious internal constitution. It's very, very low density, and the suggestion is that it's like a piece of pumice. It's porous. I'm not sure that we actually understand the reason for that. In fact, it's probably got echoes of is it Epimetheus? No, it's might be Hyperion. One of Saturn's moons has a similar composition, very, very lightweight, almost porous in the sense that it would float on the surface of water. So a very interesting place. Also has been suggested as a possible landing site for humans in their exploration of Mars. And of course, the great thing about landing on a world like Phobos is that you don't need the huge amount of energy to get your astronauts back off the surface of a planet. So getting off the surface of Mars is certainly less of an effort than getting off the surface of the Earth, but it's not that much less. The gravity is about 1/3 of Earth's. On Phobos, though, you have an escape velocity of 40 kilometres an hour, which means you could get off Phobos in a Toyota Corolla.
I was going to say, yeah. I could,
or even on a bicycle, probably.
Well, actually, the fastest I've ever ridden a bicycle is 40 kilometres an hour.
Well, there you are.
Yeah.
So if you'd done that on Phobos, you'd be on your way back home by now, in big trouble.
Or somewhere.
Yeah.
So I'd probably be able to catch that Tesla and drive that home instead.
Yeah, that's right. Yeah, you might be able to catch it on the inswing. So a really interesting world. And there has been in the past an attempt to send a probe to Phobos. This was a heroic effort. Back in 2011, the Russian space agency Roscosmos launched a spacecraft with the slightly unappealing name of Phobos Grunt. So grunt is just the Russian word for ground.
Yeah.
It's the Phobos lander, I guess. Phobos Grunt was launched on the 8th of November 2011. It went into a parking orbit around the Earth with the idea that it will be boosted into a Mars transfer orbit to head it off to Phobos. But things went wrong. It never. I think the transfer orbit rocket never fired.
It didn't have enough. It didn't have enough grunt.
Grunt, exactly. See, I set that one up for you, Andrew.
Sure did.
Didn't have enough grunt because I think the motor didn't work at all. And that temporary orbit that Phobos Grunt was in around the Earth was a very temporary one. It was not sustainable. And so the following January, 15th of January 2012, it actually re-entered and burned up in the atmosphere. It's a big spacecraft. I think it was about 13 tons. It was, it's such a tragedy that did not work. Anyway, it would have been fabulous if the mission had been successful, because it's such an interesting place. When you look at pictures of Phobos, it's like this piece of fruit in its shape, but it's got this enormous dent in it, which is a crater called Stickney. It's one end of it is just basically a huge crater, actually with several other ones inside it, smaller ones. But the other remarkable thing is that emanating from Stickney are all these grooves in the surface of Phobos, which I guess come about because of the debris. When that impact crater was formed, the debris was splattered all over that little world. So to cut to the story, JAXA, the Japanese Space Agency, has just announced that their MMX mission, which is Martian Moon Exploration mission, it's got the green light, basically, and will launch probably September 2024 is the expected launch time. The plan is to have an orbiter, which will basically orbit Mars and the Martian moon system. I think it will also go into orbit around Phobos. So as well as orbiting Mars itself, it'll orbit the moon, I think. But there is also a lander. So we expect to see images from the surface of Phobos and possibly even a rover. But I guess the really cool aspect of this is the possibility of a sample return. When the spacecraft comes back actually it will leave Mars, the plan is 2028, August, leave Mars, get back to Earth 2029, September. Of course, these dates are defined by the relative orbits of the Earth and Mars. There are only certain windows where you can actually make the transfer between the Earth and Mars. So the possibility of bringing back something from the surface of Phobos, and of course, in doing that, JAXA will build on its experience with its Hayabusa spacecraft, the two of them, which basically returned, one is still on its way back, returned samples from asteroids. The first one, Itokawa, that was back in 2005, and more recently, last year, Hayabusa 2 visited an asteroid called Ryugu, and we expect the samples from that asteroid to come back to Earth late this year and will land here in Australia at Woomera. So that is great experience for the Japanese Space Agency, learning how to do this sort of thing. And they will no doubt bring that expertise to bear when the mission to Phobos takes off in 2024.
You talked about the size of Phobos at around 30 kilometres. Is it possible it's a captured asteroid rather than our moon, which seems to have been created by an impact and ejected from the planet and forming around the parent planet? But is it possible that Phobos and Deimos are completely different types of objects to Mars itself?
Yes, I think that's a well-made point. And of course, the orbit of Mars is on the inner edge of the asteroid belt. So asteroids that tend to cross the orbit of Mars might well be captured. So they're tiny objects. Deimos is even smaller. I think it's only 10-ish kilometres or something like that. Nothing like our own moon. So I think captured asteroids is probably the way they're viewed. And that might explain why Phobos has got this peculiar construction or constitution, why it's not a solid world like most asteroids are. It's a very unusual little world. We probably won't know much about its origins until after we get these samples back from Phobos in 2029.
So the mission's purpose is obviously to learn as much as we can about Phobos and how it is there, why it is there, and what it is made of, and why it's hollow, and also to give JAXA some more experience and learn from this and move on to bigger and better missions, I guess.
Yes, that's right. And actually, on that point, it's an international collaboration as well. So the Japanese Space Agency is responsible for the spacecraft and doing all the orbital manoeuvring and all the rest of it. But there are a number of international partners too. So there are 11 instruments on board MMX, 4 of which will come from partners in international consortia, including NASA, European Space Agency, the French Space Agency, CNES, and DLR, the German Space Agency. So that these are all like guest instruments almost on board the spacecraft. JAXA will also provide instruments, including a telephoto lens, a narrow-angle camera, which will give us, I hope, stunning pictures of the surface of Phobos, and all kinds of other instruments, including a laser altimeter, a dust monitor, a mass spectrum analyzer, so we know what charged particles there are around those moons, and of course all the equipment required to take the sample and bring it back. The MMX website says the spacecraft, when it lands, it would land for several hours to collect a sample of at least 10 grams using a corer that can gather material from a minimum of 2 centimetres below the moon's surface. There you are. So
very good. Interesting. And most importantly, a low fuel warning light. I'll need one of those.
Yeah, come on, you've got to do another grunt joke somewhere in there.
I'll save
Hopefully it'll have enough grunt to get there. There you are.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, the discovery of new worlds beyond the orbit of Neptune. China's new Long March 7A rocket fails on its maiden flight. And later in the science report, paleontologists discover 3 new species of fish-eating pterosaurs. All that and more still to come on Space Time. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by Tech Radar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to Spacetime with Stuart Gary.
Astronomers have discovered more than 300 new worlds out beyond Neptune. The findings, reported in the Astrophysical Journal, are based on new data from the Dark Energy Survey and could help in the ongoing search for Planet 9. The Dark Energy Survey, which completed 6 years of data collection in January, is designed to understand the nature of dark energy by collecting high-precision images of the southern sky. Dark energy is a mysterious force, a sort of vacuum energy working opposite to gravity to push things apart. And while it only played a minor role in the early evolution of the universe, its power's been growing, and it's now likely to dominate the ultimate fate of the cosmos. While the Dark Energy Survey was specifically designed to study galaxies and supernovae, it was also pretty good at finding trans-Neptunian objects, as long as you knew what to look for. After months of data processing to remove unwanted objects and to focus on tracking nearby objects which would appear to be moving across the sky compared to more distant objects, the authors found some 316 trans-Neptunian objects, that is, worlds orbiting the Sun beyond Neptune. Included in the count were 245 discoveries made directly by the Dark Energy Survey and 139 new objects that were not previously published. Now, when you think about it, astronomers currently know of about 3,000 trans-Neptunian objects, so the additional ones gleaned from the Dark Energy Survey represents 10% of all known trans-Neptunian objects. Pluto, the best-known trans-Neptunian object, is around 40 times further away from the Sun than what the Earth is. And these newly found objects in the Dark Energy Survey data range from between 30 to as much as 90 times the Earth-Sun distance. Now that the Dark Energy Survey is complete, the authors are rerunning their analysis on the entire dataset using a lower threshold for object detection, looking for things they may have missed earlier. This catalogue will also be a useful scientific tool for research about the solar system in general. Because the Dark Energy Survey collects a wide spectrum of data on each detected object, the authors can attempt to figure out where these objects originated from, since objects that fall more closely to the Sun are expected to have different colours than those which originated in more distant, colder locations. And by studying the orbits of these objects, researchers might one day move a step closer to finding Planet 9, a long hypothesized Neptune-sized world that's thought to exist somewhere out beyond Pluto. One of the study's authors, Gary Bernstein from the University of Pennsylvania, says there are lots of ideas about giant planets that used to be in the solar system and aren't there anymore, and about planets that are far away and massive but too faint to be seen, and this new catalogue could provide a resource in the search for them. This is SpaceTime. Still to come, China's new Long March 7 rocket fails to place a satellite into geosynchronous transfer orbit, and later in the science report, a new technique to quite literally build meat grown in a laboratory. All that and more coming up on SpaceTime. China has failed to place a new classified military spy satellite into orbit using its new generation Long March 7A rocket. The mission was launched from the Wenchang Satellite Launch Center on southern China's Henan Island. However, it seems some sort of issue developed with the launch vehicle's third stage, preventing the payload from achieving geosynchronous transfer orbit. The 60-metre-tall Long March 7A is a three-stage version of the Long March 7 rocket, which has launched twice previously, both times successfully. The additional third stage is simply adapted from the older Long March 3B rocket. The Long March 7 rocket family and its variants are designed to replace the existing Long March 2F as a major workhorse for China, both for manned missions and for placing satellites into geosynchronous transfer orbits. The modularized cryogenic rockets are designed to carry 13,500 kilograms into low Earth orbit and 7,000 kilograms into geostationary transfer orbit. And time now for a brief look at some of the other stories making news in science this week with a science report. Medical experts have discovered that heart damage is common among patients hospitalised with the COVID-19 coronavirus, and it's linked to a significantly higher risk of dying in hospital. A report in the Journal of the American Medical Association claims that a study of 416 patients with confirmed COVID-19 found that cardiac injury occurred in around 1 in 5 patients in hospital. The researchers found that these patients had a 10 times higher risk of dying than those without a cardiac injury. There's more evidence that bats were the most likely source for the coronavirus responsible for the COVID-19 outbreak. However, a report in the journal Nature claims it's still unclear exactly which animal acted as the intermediate vector, which wound up passing the virus onto humans. Australian and Chinese researchers have detected other closely related coronaviruses in highly endangered pangolins, which are smuggled into China to be sold in the country's horrific live meat markets. These markets were supposed to be shut down by the Chinese government after they were found to be responsible for numerous other pandemic outbreaks, including SARS, but they remain open all over China, where animals ranging from rare and exotic wildlife to dogs and cats and even Australian koalas are sold as live delicacies. A new study has warned that the COVID-19 virus may be able to spread in warm and humid conditions such as those found in swimming centres. The research follows a clustered case of infections which had been linked to a public facility which contained a swimming pool as well as showers and a sauna. Previous reports had suggested the virus preferred cold weather and didn't do well in hot and humid conditions. But the new findings reported in the Journal of the American Medical Association suggest that this is most likely wrong, as the cluster of 8 patients all used or worked in a local Chinese bath centre and experienced symptoms within days of visiting the facility. These bath centres usually have temperatures ranging from 25 to 41 degrees Celsius. Meanwhile, Australian scientists have commenced stage 1 testing of 2 potential vaccines for COVID-19. The Commonwealth Scientific and Industrial Research Organisation, the CSIRO, says that its tests will be the first comprehensive preclinical trials for the vaccines. One's a vector vaccine, which uses a benign virus to introduce coronavirus proteins into the immune system and induce a response. The other vaccine encodes specific coronavirus proteins to the immune system, prompting the body cells to generate those proteins before the immune system can react to them. The first results are expected through as early as June, and if successful, the vaccines will then be moved on to full clinical trials. Meanwhile, the United States Food and Drug Administration has given approval for Phase 2 trials of a new Israeli drug that could take on one of the deadly conditions associated with COVID-19. Scientists hope that aviptadil will be able to treat acute respiratory distress syndrome, which has been linked to about 50% of all COVID-19 fatalities. The syndrome's a respiratory system failure caused by rapid and severe lung inflammation with shortness of breath, symptoms widely associated with COVID-19. It effectively brings to a halt the oxygen and carbon dioxide exchange in the patient's lungs, necessitating the use of an artificial lung ventilation machine. Paleontologists have uncovered the fossilised remains of 3 new species of fish-eating toothed pterosaurs. The remains of the flying reptiles were found at a dig site in Morocco. The pterosaurs date back to the Cretaceous period between 210 and 66 million years ago, with some having wingspans of more than 9 metres. That's as big as a small aircraft. The new specimens were obtained from fossil miners from a small village called Bega in southeastern Morocco, just near the Algerian border. The discovery, reported in the journal Cretaceous Research, claims the newly found 100-million-year-old pterosaurs had wingspans of between 3 and 4 metres and paper-thin bones full of air, very similar to birds. Cell-based meat is an evolving technology that could generate protein without the need for animal agriculture. Now, Israeli scientists have developed a new technique to build meat grown in a laboratory using 3-dimensional scaffolds made out of soy protein. A report in the journal Nature Food claims bovine cells were used to cover a large portion of the soy scaffolds. Volunteers report the final product both tasted and smelt just like the real thing. Homeopaths in the United Kingdom have had their accreditation renewed by Britain's Professional Standards Authority. The decision has angered medical and scientific bodies who point out that there's no scientific evidence that homeopathy works. However, as part of their renewal, homeopaths were ordered that they couldn't claim to treat a range of medical conditions, including autism. Tim Mendham from Australian Skeptics says, while the limitations are seen as good news, groups such as the Good Thinking Society are disappointed that homeopaths were given accreditation at all, and they've now challenged the decision in Britain's High Court.
Homeopathy is a treatment that's been around now for 200 plus years. That was developed by a fellow named Hahnemann in Germany in the, the late 1700s or something. And basically the idea is that like cures like, if you're suffering from lead poisoning, you take more lead, which doesn't seem like a very good idea. But basically what you do take has to be diluted, and diluted in a very strange fashion, actually. Don't forget, this was a very pre-evidence-based medicine period when this was developed, so they were not very sophisticated in their understanding of how a lot of this stuff works. But basically, if you have this material that you're sort of offering as a cure, you take a drop of it, like through an eyedropper, put it in a large amount of water, shake it up, literally shake it up, and then what used to be the case, you have to bang it on a Bible. But I don't think they do that much anymore. Yeah, something leather anyway, something leather.
So let me get this straight. So you get a drop of this stuff, just a nanogram of this stuff, and you put it in something the size of an Olympic swimming pool worth of water, I guess. And
you don't start off that way. You start off maybe a litre or something. Right. And then you shake it up, and then you bang it on something. It was a leather book or something. People used to use Bibles, so I think it was something leather. And then you take a drop of that and you put it in another litre of water, so it's diluted so much. And you do the same thing, and you keep doing it and doing it and doing it. And you might do it 30 times or something. poisoning, by which stage there is nothing left of the original medicine that you're supposedly using, but according to the homeopaths, that makes it stronger.
Okay, look, I'm not an actor or a celebrity, so I don't understand the science like they do. Could you explain how that could possibly help you?
It doesn't. Supposedly, the material that it's in, the stuff you're ending up with, which is often just water or sugar water or something that they sell, has the memory of the original powerful potion that you used and nothing else. The concept is silly. In the skeptical world, there are a whole range of different sort of medical treatments. Some you think, yeah, it might be something there. Others you think, unlikely. Skeptics are often loath to say 100% rubbish. Homeopathy is 100% rubbish. That is absolutely one we can be confident. It cannot be anything there. It disobeys all the rules of physics for a start, let alone medicine. Any effect it might have would be only placebo at best. And yet the homeopaths stick to it and get very upset, especially when the National Health and Medical Research Council, the Australian group that funds medical research, put out a paper saying homeopathy is bunk. And the homeopaths weren't very happy around the world.
So what does this say about the UK Professional Standards Authority? That must really be diminishing their standing in the wider scientific community.
Yeah, it probably does. It follows on actually from work that's been done by a group called the Good Thinking Society in the UK, actually based in Manchester. They've been working about the national health system in the UK funding homeopathy, and basically they've been fighting, saying why fund something that there is no sort of scientific evidence for. So that has been fairly effective, and they've now tried to take it one stage further and to have the UK Professional Standards Authority, which is the body that authorises medical regimens, if you like, and medical groups, etc., to get them to not accredit the homeopaths and saying, why include them amongst all the proper medicine things when this homeopathy has nothing to it? So they've been taking this thing to court to try and get homeopathy disaccredited. The PSA has given it accreditation.
How do they justify that?
Well, that's a very good question. That's what they're trying to find out. They're actually going to court in about a couple of weeks' time, actually, to try and find out.
This is the High Court in the UK now.
Yeah, the High Court in the UK. They're trying to take them to court to sort of get that decision changed. But at the same time, the PSA, the Professional Standards Authority, did make some restrictions, some caveats on what the homeopaths can do, including areas where the homeopaths claim that they can treat autism, which is not just silly, it's also actually dangerous and quite morally unsubstantiated anyway. That they really sort of, if it's offering something that they can't do, and therefore that's one good thing out of this decision by the PSA, is that limiting what the homeopaths can do, but not limiting homeopathy itself, unfortunately.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.